And we're live. Welcome back to another Corona Geek, where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever. And today, we're going to continue our conversation about 2D shadows and using gravity in games. This is going to be a brand new conversation that we're going to start this week. And if you haven't already checked out last week's conversation, we talked about 2D math, issues that can kind of come up when you're using custom shaders. And we also kind of hinted at the 2D shadows solution that we're going to look at some code for today. I'm not sure if that sentence actually makes sense, but you get the point. So joining us on the panel is Dr. Brian Burton down in Abilene.
Hello.
You can find his stuff over at burtonsmediagroup.com. Also joining us is Ed Marina from roaminggamer.com.
Howdy.
Got our Jason Schroeder from jasonschroeder.com, rocking the personalized domain. Laura Talarde. Laura, where are you these days?
I'm in Brooklyn.
No, your domain. Where can people find you online?
LauraTalardi.com.
LauraTalardi.com. So you're also rocking the personal domain. I have there's a whole conversation we could have on that. I'm really interested in how people choose their brands. But we'll have to save that for tomorrow night at the Corona Geek After Dark. And also joining us from Nijbalba Studios is Stephen Johnson. I think I said that right, but I don't know. So, yeah, if you guys haven't had a chance, go back to youtube.com/CoronaGeek. We have all our videos there. You can catch everything that's there. Ed's done some videos, from follow-up videos to last week's conversation. We've also got a new series going on, Corona Geek After Dark, where we meet every Tuesday night at 6 p.m. Pacific, 8 p.m. Central, 9 p.m. Eastern. And we talk about all things either app development or community related or just general geek foo is what I'm somewhere between geekery and geek foo. I'm not sure exactly which term I like better, but they both sound fun. So that's what we're.
Or insulting me.
What's up? Where what?
Or occasionally insulting me.
Oh yeah, we definitely it's definitely.
I know.
Punching bag Ed. No, Ed brings up a bunch of great topics, and it gets everybody excited, and we all want to talk about it, and then Ed's like, "Well, let's not talk about my topic." So it's your own fault, man. You spin it up, and then we're all over it like chihuahuas on a pork chop, and then the problem is you're the pork chop.
Chihuahuas, I like that.
You can be the chihuahua if you want. I don't care.
You definitely.
Some days you're the chihuahua, some days you're the pork chop.
Some days you're the chihuahua, some days you're the pork chop. That is a T-shirt, my friend. That is a T-shirt. That is like Confucius say. All right, enough of that. We do that on Tuesday night. What we're going to do here today is look at code. We're all about, the mechanics and the code and the technical stuff here. So let's talk about 2D shadows. Now, Stephen, you last week showed us an example of a 2D shadow / custom shader example, and we didn't have enough time to get to the code, but you got that for us today, right?
Yep.
Sweet.
To recap, it was this. And this is visible?
Yes.
Okay.
There's a green spring thing.
There was a conversation on the forum where somebody was asking how to put a shadow oriented in a given direction underneath an object. It would basically respect the direction of the light source. And the shader isn't so much necessary for that, but I realized, hey, I could use this to demonstrate multipaths. So what this is doing is using the Gaussian blur effect, which is a built-in Corona effect. And then after that, it's applying another effect on top of that.
Okay, so for the home listeners who can't see this, it's basically a coil spring with a rotating light source and
the spring itself is rotating.
Yeah, and the spring itself is rotating, and the shadows have been colorized in some manner so that you can see them better. And as everything kind of spins around each other, the shadow offsets either way depending on where the light source is.
Right. It's taking basically the relative angle between the spring's angle and the light angle.
Right. That's the technical version. The dot thingy is going around the spring thingy. Got it.
Right. And as others have said, the Gaussian blur doesn't seem to be all that fast on a device. So this is more of an illustrative example, but I haven't had a chance to run some other multipass effects through their paces. So I don't know if that's a general multipass thing or if it's particular to Gaussian blur. But in this case, you could pre-compute that and save it, and then just shift the shadow. Let's see. So it begins as a normal rectangle. This is adapted from some code on the Code Exchange by Horace Bury. I think he's Matt Webster. Not quite sure on that.
Yeah.
Okay. So he had something where you could create a drop shadow by essentially creating a slightly larger version of your image with, let's see if it's, that was all black. And then you would apply the Gaussian blur to that, and then capture. There's a capture involved.
Gotcha. And this is kind of an old school throwback to when graphic tools didn't really have a built-in shadow effect. People would do that. They would copy things, put it on a different layer, change its alpha or whatnot, and then create this pseudo shadow effect on their text or their image or their whatever, right?
Yep. And it's nice to use the effect itself because you don't have to make all the assets by hand. But it's just, at the same time, you run up against the issue with the slowness.
So in this solution, that it is in fact kind of making the copy programmatically and then applying the filter and stuff. So you're not, like you said, you're not creating image assets, but you're getting the same net effect.
Right.
Okay. Cool.
And here we see where it's setting some of the effect parameters, and already you see that this part looks like what you would see setting the Gaussian fields. These are all those same parameters. And then here, instead of the prefix blur, we have the prefix move, which is like moving the shadow with a subfield, light angle. And it's rotated in an enter frame handler. So that's the object itself has a standard rotation, as does the underlying shadow. And each frame we update the angle of the shadow based on what the two angles look like in comparison to each other. So that's just to account for both rotations going on at once.
Let me ask you, I see there's some cosine stuff going on there and some sine stuff going on there. So, like math.cos and math.sine. Do you feel like this is something that you can reference in a book? Like if I wanted to do this kind of stuff, could I reference it in a book and just kind of copy and paste the concepts, or would I have to understand the math, or what's the best way to do that?
The only thing that's doing is moving the light. So it's just a circle equation, basically. So center x, center y, radius, and then these are the two parts of the angle. So you basically just look up the equation for a circle.
And so this could be, you could say this is sort of language independent, right? I mean, it's not necessarily, again, the math library there is probably pretty generic, so it's just,
yeah.
Okay, so you could just look it up, Google it, so to speak, and then pop it into your code, and then maybe massage it to be language specific.
Yeah, and I suppose you could I was going to say you could just anchor some point, but then you can't go outside of the object. Otherwise, you could just update the rotation of the light. But
yeah, I just know that took half a semester of high school trig,
right?
Like a bazillion years ago. So when I see that, I'm like, oh, I know what that is. I know enough to know that I don't know how to do that, but I do recognize it for what it is.
Right. Well, the cosine, it looks like x divided by r. So you're multiplying that by an R, and the R's sort of cancel, and you get an X back out of that. I don't know if that's very intuitive, but that's one way to see which things should line up.